Wastewater is any water that is modified by use and enters the sewer system. By law, wastewater must be disposed of without detracting from the well-being of the community. A permission to discharge wastewater into a river or other receiving water can therefore only be granted if effective purification of the wastewater is guaranteed. Most wastewater is purified at our sewage treatment plants by the use of the activated sludge process. This process enables the biological removal of carbon and nutrient compounds from the wastewater. The permissible pollutant limits for the discharge of wastewater from a municipal sewage plant into receiving water are laid down by law as a function of the size of construction of the plant. European legislators demand reliable adherence to these limits under all inflow conditions and at all times. One of the modern German sewage plants that have to satisfy these strict requirements is the wastewater treatment plant Langen, Egelsbach, Erzhausen. This sewage plant was extended in the 90s and equipped with a modern measuring and control equipment in order to ensure an optimal and fault-free treatment process. In a modern process control system, PCS, all signals are collected and recorded, and suitable actuating variables are calculated in order to control the process. All process sections, mechanical screening stage, primary sedimentation, biological treatment, final settling, and sludge treatment are shown here. Important process conditions and measured values can be called up and displayed on the process control system. Faults are displayed instantly and can be rapidly remedied. But now back to the actual wastewater treatment process. Before the wastewater runs through the individual purification stages of the sewage plant, it is raised by a pump to a level that guarantees the free flow of wastewater through the plant. In the mechanical treatment phase, coarse solids and hygiene articles are removed from the wastewater by a bar screen. In the next stage, the aerated sand trap, mineral solids and fats settle out of the wastewater. The first process measuring technology to give an indication of the composition of the wastewater is found here in Langen at the outlet of the sand trap, even before the biological treatment stage. In order to respond rapidly to varying inflow conditions, the organic content of the wastewater is continuously measured by means of the spectral absorption coefficient at 254 nanometers. For this purpose, a UV process probe is used. This probe operates on the principle whereby numerous organic substances absorb light in the ultraviolet region of the spectrum. The probe is directly immersed in the wastewater and measures the spectral absorption coefficient, or SAC for short, at 254 nanometers. In particular, in municipal wastewater, the SAC parameter has a very good correlation to dissolved COD. The immersion probe contains a two-beam photometer. The actual absorption measurement is taken at a wavelength lambda mes of 254 nanometers. In order to eliminate the effects of turbidity in the wastewater, a reference measurement is taken at a second wavelength lambda ref. The cuvette of the photometer is formed by the measurement aperture in the probe housing, which is fully immersed in the sample. The measurement aperture is cleaned at programmable time intervals by a wiper. The display unit indicates the impurity of the wastewater as absorption in units per meter, or, after appropriate calibration, as COD UV or DOC UV. With the UV probe, it is possible to monitor the load of impurities in a sewage plant continuously. Highly polluted effluent, for example from indirect industrial drains, can be detected, provisionally stored in buffered tanks, and then released into the cleaning process at the most favorable time. After the wastewater has passed the mechanical treatment stage, it enters the biological treatment stage, which at the Langen sewage plant is constructed as a pre-denitrification unit. Here, in addition to breaking down organic compounds, the biological treatment also breaks down nutrients. Nitrification takes place in the aerated zone of the activated sludge tank. In addition to breaking down carbon compounds, This zone also biologically converts the nutrient ammonium into nitrate. The nitrate-rich wastewater is then channeled by internal recirculation to the denitrification zone. Here, under anoxic conditions, that is without dissolved oxygen, the nitrate is broken down into elementary nitrogen and oxygen. The biological breakdown reactions are triggered by the bacteria in the sludge flakes. The concentration of sludge or solids in the activated sludge tank is therefore of central importance for the treatment process. This concentration is externally influenced by the hydraulic load and internally by the sludge recirculation flow. It is therefore essential to monitor the total solids content in the activated sludge tank.